is 2a to the second power.
So negative 2a to the second. And what do we get after we factor out of the third term?
7a. I mean, no a.
Yes, so just plus 7. Good. So our first step, we found our GCF. Our second step, so on the little Google sheet, it says, is there a GCF? So obviously, you don't need to do this option, what is a GCF, because you remembered. If you did hit that button and then you click next, then it takes you to like a video to remind you, and then you can go back. But in our case, we're going to select, yes, we know what the GCF is, and we factored it out. Okay, and then next. So then the next question it always asks you is whether or not it's special. Like that's the next thing you should look for, because that can save you a lot of time if it happens to be special. So my first question is, do we remember what special means?
No.
And it's been over a month, so I totally get that. So if you weren't working with, it's been since March the 13th. Remember Friday the 13th was our last day of school?
Oh my gosh.
It's been a month, boo. All right, so if you weren't working with me right now, you would click what does special mean, you would go to next, and it would give you a little reminder video. But we're going to talk about it here right now. So those special products are, and we're going to do an example of one so it'll be a little more clear in a second. This one's not, and the reason it's not is because this term is not a perfect square. Like there's nothing that you can multiply by itself to get 10. And there's nothing like a to the third, you can't, that's an odd exponent. So you can't, like that's not a perfect square. And then there's obviously nothing you can multiply by itself to get 7 either. So 7's not a perfect square. So that's how you check to see if they're special. We'll do an example of special in a minute so you can just kind of get a reminder what I mean by that. But we're going to click no for right now because the leftover, like what's left over inside of those parentheses, is the first and the third term are not perfect squares. So we're going to click no because that would be the only test for whether or not it's special. We're going to click next. And so then the next question is, so it wasn't special, is this leftover a quadratic trinomial? So do we remember what quadratic means, first of all?
Yes, it's when the largest exponent is 2.
Yes, so when that first term has a degree of 2, in this case, is it quadratic?
No.
No, so we're going to click no. If you didn't remember, you would click that, what's a quadratic trinomial, hit next, it gives you a video. So we're going to go to no, it's not. So then the very last question you ask yourself is, do you have 4 or more terms that can be grouped? So let's just start with the easy part. Are there 4 or more terms left there?
No.
Nope. So that's going to be a negative, Ghost Rider, because we don't even need to look and see if they can be grouped, because we don't have 4 terms in that leftover at all. So we're going to click no. And then last thing, you double check and just make sure you didn't overlook a GCF. Double check and make sure it's not quadratic. Make sure there's not 4 more terms, any of that. The answer to all those questions is a solid no. So that means there's like nothing else we can do to factor this, which is why your answer for this particular problem would be D, because you can't factor it any more than you already could after you factored out a GCF. So that, oh, I'm sorry, honey, what?
I was just saying, okay.
All right.
Just making sure that I got it right.
Yep. Okay, so now let's look at number 3. So I got that one here. Actually, let me do it. I'm going to skip to number 4 for a second, and then we'll come back and do number 3. Okay, so I'm going to go back to my little Google form. All I need to do is click next and submit, and it'll let me do another one. And you might not need to use that. It's literally just there as a tool to help remind you like what questions you need to ask. So what's the very first thing you need to look for?
Is there a GCF?
Is there a GCF? So, is there a GCF?
No.
Yeah, there isn't anything that you can divide both 16 and 25 by. And p to the second power is, you've got a p there, but you don't have any p's there. So there's literally nothing you can factor out of both of those terms. So our answer is going to be no. I know for sure there's not a GCF. Okay, so then the next question is special. So for a reminder about what special means, and I'm going to move this over here to this side where I've got a little more room with the answers. So I've got 16p. Do you remember what a perfect square is? So like, can you multiply something by itself to get that? So like, for example, 16, yeah. So you can get 16 by doing 4 times 4. And then because it's p to the second, it'll be 4p times 4p. So you can get 16p to the second by multiplying the same two terms times each other. So that means that that's a perfect square. And then check, obviously 25 is a perfect square because you can get that by doing 5 times 5. So if you've got perfect squares on either side and you've got no middle term, there's only subtraction there in the middle. That tells you that this is that special case. So we're going to go to yes. We know it's special. And we're actually going to be done in just a second. Because if that means it's a difference of squares. So this is the easy one. All you got to do is pop open those binomials. You put the 4p and the 4p. You put the 5 and the 5. And then it's just 4p plus 5, 4p minus 5.
Okay.
So that one, we like special, which is why it's a question that's so up close to the front, because that one's really easy if you recognize the structure. And so that's literally all that you can do. So that's why the strategy sheet goes right to the end, because if you recognize that it's special, you should be all good.
Okay.
I'm going to jump back up to number 3 also here. Okay, so, because 3 is one of the ones that's got a lot of work to it. Because you got to do, well, never mind, I won't spoil it. Okay, you tell me first, what do we need to do?
Find the GCF.
Look for a GCF and see if there is one. Yes, ma'am. So is there a GCF?
I'm pretty sure that there is.
Okay. And for the record, like, I know we weren't using calculators in class at this point. I know everybody's at home. It's whatever at this point. So you could even use your calculator, honestly, to kind of take a good guess about what you think the GCF would be and see if it works for everything. So what do you think? There is definitely a GCF. I'll go ahead and tell you that. What do you think it might be?
Well, I'd already started off a little bit on this point, but I never finished the question, so I know it's 6.
Yeah, it is 6. You're right. So we're going to factor a 6 out of each of those. So after you factor out, I'm going to scooch it over here. So after you factored out that GCF, then what are you going to have left over in the first term?
5.
5A. Right there. Just 1A?
Oh, to the second.
Yeah, that's going to be important in a second. So 5A to the second. And then what do you have left over in the second term after you factor out the 6?
Hold on. Wait, is it 52?
Yeah. Sorry. I had my own brain cramp moment for a second. 52. 52 what?
Okay.
Yep. Okay. And then I know you know that's 20 left in the other one, right?
Mm-hmm.
All right. So, next question you need to ask yourself is it special? So, in that leftover, do you have a perfect square in both of those places?
No.
No, you do not. So, can't be special. So, now what's the next thing you need to ask?
Is it quadratic?
Yes, quadratic trinomial. Is it?
Yes.
Yes, it is. So then we haven't reviewed this part yet. So then, you get off easy as long as A is 1. That's a much easier method to factor. Is A 1 in this case, though?
No.
Of course not. I wouldn't give you an easy one like that, would I? Well, actually, there are a couple like that. Okay, because A is 5 in this case. So whenever you've got a quadratic trinomial and A is not equal to 1, you got to do that AC method. So the first thing we need to do is multiply. I'm going to do it down here. A times C. I'm going to make myself a little chart. So what number is A and what number is C?
5A squared is A and 20 is C.
Right. So A times C is obviously 100. So this is the one where you need to set yourself up a chart where you need to figure out what can you multiply to get AC. So what can you multiply to get 100 that you can add to get B. And in this case, B is negative 52. So start thinking of factors because that's always easier to start with. You can multiply to get 100 and we'll see if we can get them to add up to 52.
1 and 100?
All right, so 1 and 100. Is that going to get us to a 52?
No.
Nope. Okay, so what's next? But thank you for actually starting at the beginning and going in order because I feel like that makes it a lot easier for you to not miss one. And so far when I've been doing these, nobody does that first, so thank you. So what's the next one we're going to move on to?
2 and 50?
All right. Does 2 and 50 give us 52?
Yes.
Yeah, with a slight adjustment though, right? So we're going to have to do negative 2 and negative 50 because negative times a negative will still give us that positive 100 that we want, but it also adds up to that negative 52 that we need it to add up to. Okay, so now that we have found those two factors, AC method is the one that's really doing the most. The whole point of finding those two numbers was now we're going to take this original leftover up here, and we're going to take that middle term, and we're going to split it in two, so that now it's going to be negative 2A plus negative 50A. And then I'm going to bring the other terms down to go with it. Does it make sense what I just did there? I know I just kind of did that fast. Did that make sense why we did that?
Yeah, so you can make it a... Wait, so you make it... So there are 4 terms?
Exactly. Yeah, the whole point of taking that middle term and splitting it up is now you've got 4 terms, and we know that when you have 4 or more terms, you can factor by grouping. So now we'll be able to do that. So I'm just going to group those first two together just because they're sitting there and I can group something out of them, or I can factor something out of them. So what can you factor out of that first group that I just underlined in blue?
A.
Mm-hmm. Yep. And what can I factor out of this green group right here?
10.
Yep. So the next thing we're going to do is factor each of those GCFs out of there. So I'm going to factor out the A. And then my leftover, I know that if I had 2 A's and I factored out an A, that means I'll have 1 A left over. And then that 5 didn't get factored out anywhere. So I have 5A left over. And then here I still have the minus 2. But I don't have the A anymore because I had 1 A and I factored it out. So after I factor out that blue A, I've got 5A minus 2. Then I'm going to factor out the 10. Tell me if I need to slow down or anything. And so here you've got your negative 50 divided by 10, which means you'll have a negative 5A. And then 20 divided by 10 gives me plus 2. So how do we know, do you remember, again, it's been a month, so if you don't remember, that's cool. Like, we can kind of gauge that we're probably on the right track at this point. We've done a crap load of steps, but we've probably done them right because of the way this problem's shaping up. Do you remember what that is?
Because the two things are almost identical.
Exactly. They're almost identical. Is there a way, because that's what we want those to be 100% the same, though. So do you remember a way that we could get them to be the same by making a little adjustment? If not, I'll remind you. No biggie.
Yeah, I don't remember.
Okay. Instead of factoring out a positive 10, I'm going to change that to a negative 10. Because when I do that, it's going to flip the signs of everything. So when I divide negative 50a by negative 10, now that's going to become a positive a, just like the one in the other binomial. And then if I do positive 20 divided by negative 10, that'll make this a negative 2. So by factoring out the same number, but all I did was change the signs, I just factored out a negative 10 instead of a positive 10. That flipped the signs of everything in here. So now these two binomials match. So then we're finally almost done. We're gonna, I know these are doing the most. AC is the most. So we're gonna factor out that 5a minus 2 that they had in common. And then we're gonna put in that a becomes part of the second binomial, and then the minus 10 becomes the piece of the other binomial. So it's not quadratic anymore. We don't have a greatest common factor. We don't have 4 or more terms anymore. We've just got two great big things that we multiplied together. So it's not special, obviously. It wasn't special before. It's not all of a sudden going to become special now. Well, that's not true. I shouldn't say that. In this case, it didn't. So I'm almost finished. There's one. If this were a short answer question, I would have done all this work, though. Because this is multiple choice, I'm probably going to realize my mistake because my answer isn't quite there. But if this were a short answer, we would do all this freaking work and then maybe miss like half a point because we forgot one little thing. What's the difference between the multiple choice answers we've got over there and then what we've got? Yeah, that greatest common factor that we factored out right at the beginning. Now, he's literally done jack squat. He's kind of like the loser on your couch that's just hanging out there, but he's still there. So when you write your final factored form, you got to put him right there in the front. Like, don't forget about him after you did all that factoring. So that means that the correct response is going to be B in this case. All right, so tell me step 1.
See if there's a GCF.
Yep. So is there a GCF?
Yes.
So what can you divide 4, 31, and 90 by?
Wait a minute. Okay, I changed my answer.
Okay.
I do not think that there's a GCF.
Okay, you are right. There is not a GCF. Okay. So what is the next thing that we need to look for?
Is it quadratic?
Yes. Is it a quadratic trinomial? Well, first we need to look and see, is it special? So let's start there. Is it special? So I'm going to pull 4x to the second. I'm going to put it down here so it's easier to check. So first of all, 4x to the second, is that a perfect square?
Yes.
Okay, what is that?
2x.
Yeah, so you can multiply 2x by 2x. And then what about the 90?
I don't think so.
Yeah. A lot of people have been saying 30 and 30, and it would have to be 900 for it to be 30 and 30. Yeah, so we're not.
That's what I thought at first.
Yeah, exactly. See? It's like I already know. All right, so it's not special. So now it's a what?
It's a quadratic.
Quadratic trinomial, yes. So what do you ask yourself after it's a quadratic trinomial?
Is the quadratic one?
Is the A1? Yes, ma'am. Is it?
No.
Nope. So what do we have to use if A is not equal to 1? Mm-hmm. Yep. So we're going to multiply A times C. So what do you get when you multiply A times C?
Give me a second.
No problem.
Negative 360.
Yes. Okay. So then what do you have to do once you get that 360? I'm sorry, I'm bringing something else up real quick. So what's the other thing you got to, so what do you got to, why did I make that chart? What are you going to use that for?
To find out what you can multiply to get 260 and add to get 31.
Okay, yep. So what do you multiply to get negative 360 that you can add to get negative 31? Good job. Or that you can add to get 31. Sorry, I don't know why I just said negative 31. Okay, so negative 360 obviously has a crap load of factors, doesn't it?
Yeah.
So for that reason, it makes sense to go in order so that you don't forget one. So that you, so it's even more important that you like do that in order. So what do we want to start with?
1 and 360.
Okay, so 1 and 360. Okay. And, oh, sorry, I just realized I hit the wrong thing. Okay, so 1 and 360. Obviously, that one's probably not going to work, right? To get us to 31. Yeah. Okay, so what next?
2 and 180.
2 and 180. Now, the other thing we need to keep in mind is that that's a negative 360, right? So what does that tell you about the signs of the two numbers that we're multiplying together?
We need to change them?
Like one of them's going to have to be a positive and one of them's going to have to be a negative. So I'm not going to write that out, but I'm just thinking to myself, like in my head, I know like what I'm really going to end up doing is subtracting whatever these two numbers end up being to get to 31. I'm just not sure what they are yet. Okay, so what's next?
3 and 120.
3 and 120. Okay. Okay, get that to be 31. So what's next?
4 and 90.
4 and 90. Okay.
5 and 72.
Is that right? 4 and 30. Yeah. Oh, good job. Yep. Okay. Is that going to get us 31?
No.
No.
And then 6 and 60.
Mm-hmm. Man, this one sucks. All right. Do we have any other factors of 360? That's why I wanted to do this one, because this is one people have gotten stuck on a lot.
Are we going to include 7? Because that's a kind of ugly number.
Okay, 7. I mean, we're going to try it out, but I can go ahead and tell you that 7 isn't a factor of 360, but I'm glad that you're thinking, okay, well, next would be 7, but 7 doesn't work. So you make sure you don't skip
Okay.
one. Okay, so what else we got?
8 and 45.
Okay, I feel like we're moving in the right direction. That's still not going to get us to 31, but it's getting us closer. Do we have another one?
Yes. 9 and 40.
Okay. And then, so, will 9 and 40 get us to 31?
Yes.
It sure will. Which one of those has to be negative?
9.
Yeah, so one of them has to be a negative number because that's a negative 360. So, negative 9 plus positive 40 also equals 31. So what was the whole point of doing all that work to get that negative 9 and that 41? What are you going to do with it now?
To make it have more terms.
Okay, how am I going to accomplish that?
By changing the 31 to negative 9 and 40.
Yep, so I'm going to change the negative 31x to negative 9x plus 40x. So that is going to leave me with a 4x to the second minus 9x. I'm just going to bring down the rest of it. And then what do I do?
Factor by grouping.
I do, yeah. So what am I going to factor out of that first group? Yep. And then what do you want to factor out of this second group?
10.
Yep. I agree with that too. All right, so what do you do after you found that GCF for each group?
Wait, could you ask the question again?
Yeah, so what do I do after I've found that X in the green group, so then what do I do?
You write out the thing that's left.
Yep, so what's going to be left over?
4x and negative 9.
Yep. So then I'm going to factor out the 10, and what do I have left over after that?
Sorry.
Oh, I get it, boo.
4x and negative 9.
Right, so we know we're on the right track because those two binomials are almost the same. Oh, they are the same, duh. Okay, so what are we going to do?
Wait, is that it?
Well, we still got to do one last step. We got to factor out that common binomial. And then the x plus 10 that you got from the last step goes inside of there. And so now we're done because it's not quadratic. It's not 4 more terms anymore. We didn't have a GCF to start, so we don't have to worry about finding the loser that was hanging out on the couch to bring him down. This was just our final answer, which means this one's gonna be what, C? Yeah, C.
Yeah.